Hey folks, it's Mr. Glover here. So the topic today is on investments and loans. It's kind of an extension of what we did last class with investments and compound interest. But the difference today is that we're not going to be talking about using one-time investments and sitting on your money. We're going to be talking about what happens when you introduce payments. And then as we do that, we'll talk about two different situations where you will be making payments. So first and foremost, let's sort of define what investments and loans are, talk about a few terms that we're going to need to do the math here. So far, we've used exponential functions to model the growth of a one-time investment at a given interest rate. While this formula is useful, it has its limitations. Not everyone has a large sum of money to invest all at once. In fact, most people don't, unless you have money. That's where having money makes making money easy. If you could give me some money, I could grow that money, but without the money in the first place, it's not that easy to grow it. For most people, making smaller payments is the only option. Today, we will be talking about two types of calculations, investments and loans. So let's start off by defining what's called an annuity. An annuity is a series of equal deposits or payments made at equal time intervals. Each deposit is made at the end of each time interval. In this course, we will discuss two types of annuities, investments and loans. So one thing to be really cautious about, it's hidden in the words here. Each deposit is made at the end of each time interval, and we have equal time intervals. So there's very specific requirements for the formulas we're going to be using to work. Otherwise, they will be close, but they're not going to be exact. You've just got to be careful about that. If you just make a deposit whenever, you might end up with different values. And if they aren't spaced out equally, then again, you're going to have some different values. So let's talk about two other terms. And we've talked about these a little bit before, but I want to define them and I want to be really explicit about sort of how they work and what they are. First one's called present value. So the present value is the value in the present, as you might have guessed, of a sum of money, in contrast to some future value it will have when it has been invested at compound interest. So think of the present value as being like, how much is it worth today? Like, for example, let's talk about a loan. Let's say you take out a loan, and you take out a loan for $20,000. The present value of the loan is $20,000. If you add up all your payments plus the interest, you will end up paying more than that. So the future value of that loan is greater than the present value of that loan. But in terms of today, the amount of money you are borrowing is your present value, okay? Compare that to future value, which, again, it's the value of a future sum of money. Future value takes into account the growth of the sum that has been invested. So it's easier to talk about these with loans because the present value is going to be sort of what you borrowed, and the future value will be how much is all the money that you've given them worth after they invested. It's easy to explain these in terms of a one-time investment. The present value is like your principal. How much did you put in today? The future value is how much does it grow to in the future. So there's like this fine detail that separates future and present value, and that detail is the growth of your money over time. Without interest, there will be no change, but assuming there is interest, there's a difference between what your money is worth now and what your money is worth later. That's the difference between present and future value. Okay, let's talk about investments. So when a series of equal investments is made at equal time intervals, and the compounding period of interest is equal to the time interval for the investments, the future value of the investment is given by the formula A equals R times 1 plus I to the power n minus 1 to the power, or divided by I. In your book, they call A the amount, which I think is a really stupid term, but I'm going to call it the future value, which is more specific. It's the amount of money you will have in the future when your payments grow at a given interest rate. Now, there's a few things to be careful about here. You're making your payments at equal time intervals. Your compounding period of the interest is equal to the time intervals for the investments. So this only works if you're paying monthly and the compounding periods are monthly. Otherwise, the numbers will be slightly off. I'm not going to trick you and give you questions where they aren't equal. If you're going to use this for your own personal investments, you want to estimate, just realize that your numbers are going to be slightly off. And that depends on when the compounding periods are and when the payments are. In this formula, A is what's called the future value, same as it's been in other formulas. R is going to be your regular investment, or it's going to be the payment that you make. I is the interest rate, but be super careful here. It's the interest rate per compounding period. It's not just I anymore. And N is the number of investments. Again, you've got to be careful. This is not the number of years. This is the number of payments you will make. So you've got to be a little bit cautious. All right, let's try a question. Tyson really wants to buy a Porsche 911 so that he can go cruising in the summertime. He found one in Grand Prairie for $100,000. Tyson decides to start saving up for it, so he opens a savings account. Tyson chooses an account that pays 6% annually compounded monthly. How much will Tyson need to pay monthly in order to buy his Porsche in 20 years? And I suppose we should have a question. So, as with every one of these questions, we list out what we know. He is saving up for $100,000. So he's got a future value, or A equals $100,000. He chooses an account that pays 6% annual interest compounded monthly. So we need to calculate I. I is 0.06 per year. We need to divide that by 12 to figure out our monthly interest rates. This is 0.005 monthly. Be really careful with this step. He wants to buy his Porsche in 20 years' time. So in this case, N is going to be 20 years times 12 payments because he's paying once per month. So he's going to have 20 times 12, which is 240 payments. All right, so I mean, we can ballpark this. We could just say what's 100,000 divided by 240. He's going to be paying $416 if he has no interest. So we should expect our answer to be slightly lower than $416 because he's getting interest on his investment. All right, so start with our formula. A equals R times 1 plus I to the power n minus 1 divided by I. Okay, and now we've got a decision to make. Do we want to just multiply our variables and move them around, or do we want to plug in our numbers first? I always recommend you move your variables before you put numbers in because it's going to be cleaner and you're less likely to make a mistake. So we want to solve for R. We want to figure out what's his regular payment. So we move our numbers. We multiply by I to get rid of it. So A times I divided by, actually we'll just do this one step at a time. A times I equals R times 1 plus I to the n minus 1. All right, now we need to get R by itself. So we need to divide this entire term away. We can do that because it's all in brackets, fortunately. So I'm just going to say A times I divided by 1 plus I to the n minus 1 equals R. Now we're at the point where we can plug in some numbers. So A is our future value, that's 100 grand, times I, which is our interest rate, which is 0.005. Now our denominator is 1 plus I, so it's 1 plus 0.005 to the power n, which is 240, minus 1. You can do this in one shot, or you can do this in 2 calculations. I think I'll do it in 2. So 100,000 times 0.005 is 500. Divided by 1.005 to the power 240 minus 1. Make sure you put your whole denominator in brackets. end up with 500. You end up with $216.43. So now we should ask ourselves, does this make sense? Well, he's not paying 416 bucks, so he's definitely getting a better deal than if he had no interest. We also have to realize this is over 20 years. If he's earning 6% per year, if it was a standard investment, the doubling time on that would be 12 years. So he's gone past the doubling time, but he hasn't put all his money in at the start. This seems reasonable, this number. That shows you the power of interest. I would rather pay $216.43 a month than $416. That's almost half. If you have no interest, your money will not grow. If you do have interest, it will. All right, let's try another one. Alan decides he wants to save up for retirement as soon as possible as he graduates high school. He decides to invest $200 per month into an account that pays 5% annually, compounded monthly. He starts at age 17 and stops at age 65. How much money will he have in his retirement account? All right, so we've got to unpack the question and write out what we know. Okay, so we'll start out. He has regular payment R of $200. R equals 200. He's investing in an account that pays 5% annually, so I equals 0.05 per year. We have to then divide that by 12, which of course doesn't work out nicely. This is probably one that might be more accurate to do all in one shot, but let's just say 0.004167. It keeps going, it's irrational, but that's fine. This will be close per month. He starts at age 17 and he goes to age 65. So his term end is going to be 65 minus 17, which is 48 years. But he's paying this monthly, so we then have to multiply 48 by 12. He's going to make 576 payments. All right, what else we need to know? I think that's it. We just need to figure out what's the future value going to be. We don't know A. Think to yourself before we do this. Do you think it's going to be reasonable for you to put $200 a month away? It might be hard in high school when you're not working full time, but if you plan your life according to your income level and you don't live beyond your means, you should be able to save a decent portion of your income every month. So I would tell you $200 is fairly low for retirement, but if you start early, it's very doable, okay? Think about how much money you think this is going to become. I mean, we can just do it. We can estimate it. What's 576 times 200? You will end up with, you will have paid $115,200 if there's no interest. We will see this number is much bigger than that when it's all said and done. So write our formula. A equals R times 1 plus I to the power n minus 1 all divided by I. Okay. Fortunately for us, it's already solved for future value. We don't even need to rearrange this. We just need to put in our numbers. So he's making a regular payment of $200 times 1 plus I. So 1 plus this ugly number, 0.004167 to the power of 576 minus 1, all divided by this ugly number, 0.004167. If you want to keep it exact, put this in as 0.05 divided by 12. Do it all in one shot in your calculator. But for the purposes of this class, I think we're okay. I'm going to simplify the numerator. So 1 plus okay, so this becomes 200 times 9.968 all divided by 0.004167. All right, and at 5% interest, $200 a month will net him $478,442.52. And you're probably thinking, well, what? He's only got 478 grand. Well, that's 4 times the amount of money he would have had. He has a fairly low interest rate. 5% is not the, you could probably do better than 5%. You'll take on risk. So he's picked stable investments. And he's only paid $200 a month. If instead, let's say he paid $500 a month, okay, 500, doing the same thing, 500 times 9.968 divided by 0.004167, you will have $1,196,064.32. If you introduce a higher interest rate, you will see this money very rapidly shooting up. But I wanted to pick numbers that are somewhat realistic. 478 grand is enough to retire. You will live very modestly. I would encourage you to try to shoot for $1 million, which is kind of crazy to think about. Because I remember a time when $1 million wasn't a lot of money, but for now, this is doable. If you set yourself up where you're not paying your mortgage and you're not buying new appliances and you're not buying new cars and you're not traveling all the time, you can live on this. If you take 4% a year, 478,000, you'll have an income of about 19 grand, which means you'll have an income comparable to minimum wage today. Not quite, but comparable. But that's if you don't have any bills. If you have minimal expenses, that's not too bad. I would shoot for a little more than this, whether that's through higher interest rate or number of investments. It's up to you. In addition to future value, we can model the repayment of a loan using the present value formula. When a loan is taken out from a bank, the amount borrowed is known as the present value. If a series of equal payments is made at equal time intervals and the compounding period for the interest is equal to the time interval, then the present value of the loan is given by this formula. This formula is really similar to the other one, but the difference is that instead of 1 plus I to the negative n, 1 minus 1 plus I to the negative n, the other formula is 1 plus I to the positive n minus 1. The best way that I can explain this, the formula we had used before this is for growing your money. That is where interest increases the amount of money that you're saving. This formula is used when you're making payments for something. In this case, interest is hurting you. This is not helping. So if you're taking out a loan, you want to shoot for the lowest interest possible and pay it off in the shortest time period possible. But sometimes it's not an option, like a mortgage, in which case you'd better just pick the lowest interest rate and try your best to pay it off as soon as you can. If you've got extra money, make a few extra payments, because what happens is that a portion of your payment gets paid to interest. And so the principal of your loan doesn't go down as fast as it would if there was no interest. Again, R is your regular payment, I is the interest rate per compounding period, and N is the number of payments. Okay, Adara wants to buy a new laptop. She decides on a MacBook that comes with a financing plan. She agrees to pay $75 per month for 48 months. Financing plan has an interest rate of 12% annually, compounded monthly. A, what's the present value of her loan? What is the price of the laptop? That's the present value is like how much money is this loan worth today. If you then multiply all your payments by the term, you'll see that you've actually given them more money than the present value. It's just like money has a value over time. It's called the time value of money. Having $100 today is better than having $100 in 10 years. So you want to make sure that your future value of your money is worth more than the present value of your money. So the present value is the amount her laptop actually costs. The future value is how much she's actually going to pay. Okay, let's break down the problem. She's paying $75 a month, so R equals 75. She's going to pay this for 48 months. So N equals 48. This financing plan has an interest rate of 12% annually. So I equals 0.12 per year. If we divide that by 12, that's 0.01 per month. Okay. And then lastly, we need to find A, or I guess not A, it's PV in this question. I should write that. PV is the present value. And so we're just trying to find that. All right, so we'll write the formula. This will be part of it. Present value equals R times 1 plus I, or sorry, 1 minus 1 plus I, so power negative N, all divided by I. In this case, R is the regular payment, so we can plug in our numbers now. R is $75 times 1 minus 1 plus I. I is the interest rate for compounding period, so 1 plus 0.01 to the negative N, so negative 8, all divided by I, which is 0.01. We can simplify this a little bit if we want. Let's maybe simplify those brackets on the top. So 1 minus 1 plus 0.01 to the power minus 8. This will become 75 times 0.3797. Again, I'm rounding this, so it's not going to be super precise. All divided by 0.01. All right, and we end up with a present value of $2,848. Okay, $2,848.05. So we can think of that as being like how much the price of her laptop was before she agreed on this loan, or this. Companies won't call them loans; they'll call them financing plans. But it's a small loan, and usually financing plan is a license to give you a bad deal in terms of your interest rate. Like, I'll tell you a little story about getting a card for a furniture store like the Brick, for example. And most of them do this. It's not just the Brick, but I went there and I bought a couch on some financing plan, and it's basically a credit card, but they have a deal where if you use their card, you get a certain amount off, and if you pay it back within a certain period of time, then you don't pay any interest. But if you miss the deadline, you pay all of the interest for the whole term. So I knew what this was all about beforehand. I made sure I paid it off in advance. It was probably, I think it was about $3,000 or something like that. Okay. The interest rate was about 20%. If I had not paid it off by the deadline, the next month I would have gotten a bill for 20% per year for 2 years. I would have ended up paying about 40% of the value of that couch. Not quite, because there's paying down the principal as you go, but I mean, I would have probably gotten a bill somewhere in the $500 range, up to maybe even $1,000 range, which is pretty crazy. That's the difference between understanding the terms and meeting them versus maybe something happens and you aren't able to make your payments, and now suddenly you've got an extra $700 bill. So be very careful with loans. Okay, so we figured out the cost of her laptop, or the price of the laptop. Okay, so now part B. Part B is how much was she paying in interest? Well, if we take her regular payment and multiply it by 48, so she total paid is going to be $75 times 48. Okay, so 75 times 48. That means she's paid $3,600. That's the future value of her loan. If we subtract the amount of the present value from this $3,600, that's all interest. So interest is the $3,600 minus 28 4805. She will have paid $751.95 in interest. So Dara paid $751.95 in interest. If you then compare that to the price of her laptop, $751.95 divided by 28.48, she paid almost 26% in interest. That's a lot of interest. But for some people, I suppose 750 bucks is better than waiting. But if you, now this is where discipline comes in, and this is the hard part for most people, and I have the same issue. If I had put that 75 bucks in a bank account and the interest was growing my money and waited 4 years, I could have bought a much nicer laptop, the $2,800 laptop. But it's this idea of instant gratification that so many people fall victim to. Get it today, pay a slight bit in interest, but then the slight bit ends up hurting you a lot. And if you do that with multiple purchases, you can dig yourself a hole that's hard to get out of in the long term. So you really have to be careful about this. Credit cards have a 20% interest rate, sorry, 19.99. That's really scary. If you don't pay that off, you're going to pay huge money by floating a balance on your credit cards. Okay, one more question and we're done. A mortgage is a type of long-term annuity that is usually used to purchase a home. Well, I mean, some people might have the cash, but most people take out a mortgage. While interest rates on mortgages appear to be low, you'll see interest rates like, oh, it's only 3% interest, that's nothing. The problem is that mortgages take a long time to pay off, so they're longer term, usually 20 plus years, ends up costing the homeowner a lot of money. And we're going to see just how much in this example. The term of mortgage is usually referred to as the amortization period. All right, so Lynn Leander decides to buy a home in Fort St. John. She decides on a home that costs $500 grand. I don't think you want to do this for your first home unless you've got a fairly high income. And we'll see what her payments are in a second. The effective interest rate on the loan is 3.6% annually, compounded monthly. She agrees on a mortgage that has a 25-year amortization period. A, calculate what her monthly payment will be. B, calculate how much she pays in interest. So we need to unpack the question. Her present value of her loan is 500 grand. That's how much the loan's for today. So PV equals $500,000. The effective interest rate on the loan is 3.6% annually. So I equals 3.6% annually. So we need to first divide that by 100. And then we have to divide it by 12. This equals 0.003 monthly. And we needed to do that because she's paying monthly. She agrees on a mortgage that has a 25-year amortization period. So N is 25 years, which multiplied by 12 is 300. So she's making 300 payments to her house. All right, so 300 payments is costing her, she's doing this for 25 years, 3.6% interest. I think you'll see she pays a lot. All right, write out the formula. Part A. Present value equals R times 1 minus 1 plus I to the negative N, all divided by I. Now we've got to solve for payment, just like we did before, but this time it's a slightly different formula. So we're going to multiply by I, so I times present value is R times 1 minus 1 plus I to the N. We still need to solve for R. So we have, we've got to get rid of these brackets. Fortunately, they're in brackets and we can just divide it all. So I times present value all divided by 1 minus 1 plus I to the negative N. equals R. Now we just need to put in our numbers. The interest rate was 0.003 times the present value, which is $500,000. We're going to divide this by 1 minus 1 plus 0.003 to the negative 300. And we've got a bit of simplifying to do. Let's simplify the top first. So 0.003 times 500,000, 1,500. Now let's simplify the bottom. And we'll do the last calculation. So she would be paying $2,530 a month and 1 cent. And you might not think that's too bad, but if you're paying $2,500 a month for your mortgage, you better be bringing in like 5 or 6 grand a month or more in income. For a lot of people, that's a lot of money. You don't want your mortgage to take up half of your income or more. You want that to be as low of a number as possible. Trust me, once you add up all your other bills, you don't want to have like $1,000 a month to pay for your food and your car and everything else in your life. Unfortunately, you'll find that a lot of people overdo it when they buy a house and they end up getting stuck. All right, so whatever, she can afford it. Leanna's making big bucks doing whatever she's doing. Now it's time to figure out how much she's paying in interest. Okay, so we've got to figure out how much she paid in total, part D. Total paid. That's going to equal her payment, which is $2,530.01. And we're going to multiply that by the number of payments, which is 300. And her measly 3.6% interest is going to cost her tons of money because she's paid at the equivalent of $759,000. Sorry, $759,004.07. Now let's figure out how much she's paid in interest. We take this and subtract the actual present value, so $759,004.07 minus 500 grand. She paid $259,004.07. In interest. This is why you have to be really careful about long-term loans. A lot of times people will think like, oh, I've only got 10 grand on my credit card, let's just roll that into my mortgage. Well, you're paying that mortgage for 25, 20 years. Even 3% interest for 20 years is going to be way worse than just paying your credit card off over the course of a couple of years. Go get a line of credit, get something that's lower interest than 20%, dump your credit cards onto that, and then pay it off over 2 to 5 years. But if you roll something into your mortgage, term is going to kill you. She paid more than 50% of the value of her home in interest. This is the situation, unfortunately, that way too many people are in right now. This is not small money, 259 grand. You could buy another house for that much money. She paid that literally in interest. That's not improving the value of her home whatsoever. So smaller interest, shorter term, as much as possible. If you can't, then maybe you should look into buying a less expensive home. All right, that's where we're going to end things here. I've got a few questions for you to try. Question 3 is basically just calculating interest rates per compounding period. 5 through 13 are the ones that are going to be actual problems to solve. We've got a little mix of borrowing questions versus investing questions. Hope you all have a great rest of your day. If you've got any questions, shoot me an email and I'll try to answer them. And if not, then I will see you all tomorrow in our meeting. All right. Bye for now.